Good afternoon, everyone, and thank you for joining us today in our heat pump one-on-one webinar, part of Ask an Expert webinar series delivered to you by City of Toronto and Clean Air Partnership. The way that the webinar will go today is we're going to do a land acknowledgement and then introduction of the webinar series. And then Sanao Sridharan from Mitsubishi Electric will do a presentation on everything that you need to know on heat pumps. We acknowledge that the land on which we operate is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. We're going to share a short video where we're going to learn something from Indigenous person, and it's about the meaning of growing long hair.
As Anishinaabe people, we believe that our hair is seen as like an extension of our spirit. So we believe what makes us human beings is we have four parts. You know, we have our mind, we have our body, we have our spirit, and we have our heart. And so we almost view our hair on our head like an extension of that spiritual part of us, as opposed to just being something that grows off of our body. And the reason that we braid it into these three strands is because we believe that when we braid our hair and braid our spirit into those three strands, it's actually honoring and representing very important parts of ourself. So things like our mind, our body, and our spirit. Those three strands that we braid together are also recognized and seen as being our past, our present, and our future. These three strands also represent those before us, ourselves, and those after us. So those previous generations, ourselves, and those future generations. And those are often described as what we call our 7 generations. So a lot of people will think that what that means is 7 generations before us and 7 generations after us. Our 7th generation includes ourselves, and we exist in the middle. So if you are young enough to remember your great-grandparents and you are fortunate to grow old enough to meet your great-grandchildren, you will have witnessed your 7 generations. So it's actually 3 generations before you and 3 generations after you. So I've been growing my hair for 4 years. I started growing my hair when I really began taking my culture seriously in my first year of university studies, as well as the first year that I started content. And so I've come a long way, and I really do feel that having this longer hair has given me strength and helped me get through some really hard times and some difficult times. So anyway, whether you've been thinking about growing your hair or maybe you've never thought of it at all, maybe use this video as a bit of inspiration to maybe start growing out your hair. Especially us Anishinaabe people, our long hair is such a big part of our own identities, and sometimes growing your long hair and honoring that part of our culture sometimes fill in pieces of our identity that we didn't know were missing. So just something to consider. But remember, having long hair or not having long hair doesn't make you any less or any more Indigenous than anyone. Just long hair and the teachings of having long hair in our culture has been something that's been very lost due to colonization, the residential school and boarding school systems. And so it's really important that we revitalize these teachings. And so growing your hair long can be one of those ways that we revitalize those lost teachings. Now, those are my thoughts. Miigwech for listening, and I'll see you in the next one. Miigwech.
Miigwech for listening with me as well. Moving to Who Are We? Clean Air Partnership is an environmental charity that works to transform cities into more sustainable, resilient, and vibrant communities where resources are used efficiently, the air is clean to breathe, and greenhouse gas emissions are minimized. Clean Air Partnership convenes networks, lead research and knowledge transfer, and catalyze transformative action. I will share a link to our website so you can take a look in your time. Homes and buildings that use gas or fossil fuels for heating and hot water are the largest source of emissions in Toronto today. To address the climate emergency, we must switch our homes and buildings to cleaner energy sources and make them much more energy efficient. The City of Toronto offers a range of programs, such as the Live Green Toronto program, and funding and supports to help Toronto homeowners develop their own net zero pathways. I will share a link to their website as well shortly. And now I wanted to introduce you also the coordinator for this initiative. Abraham is an experienced natural resources Canada Registered Energy Advisor and Quality Assurance Specialist, as well as HBA Net Zero Energy Advisor. Abraham is passionate about eradicating energy poverty, educating homeowners on energy efficiency upgrades in their homes, and providing clear, detailed retrofit scope of work for builders and renovators. Abraham is currently the Senior Energy Consultant with the City of Toronto, providing expert advice on anything single-family residential home energy efficiency related for City of Toronto homeowners. He's here on the back end, and he will be jumping in, answering some of your questions in the Q&A session of this webinar. And now I wanted to introduce our guest speaker, Sanal. Sanal has been with Mitsubishi Electric Sales Canada for about 18 years, and in the last 3 years has been responsible in the HVAC division for business development and strategic accounts, primarily working with customers who are committed to improved efficiency and reduction of greenhouse gas emissions. In this role, he works with various cities, regions, and developers to promote the use of Mitsubishi electric heat pumps and automatic hand dryers, which vastly contributes towards achievements of sustainability goals and greenhouse gas emissions reduction. Thank you, Sanal, for being with us today. Very quickly, our upcoming webinar is how to choose a contractor. This is gonna happen on Wednesday, April 10th at noon, and I will share registration link to that as well. So now you can take it away. And while you're doing this changing of the screen, I just want to remind everyone to write your questions in the Q&A box, and we'll have time after Sanal's presentation to answer them. So now take it away. Oh, you're muted.
Perfect, that works. Can you hear me?
Yes.
Perfect. So I was saying thank you very much for the opportunity to share this presentation with all of you. We're talking about heat pumps 101, and I'll very specifically talk about how the heat pump can become your most energy efficient heating and cooling appliance, and we'll take it from there. Let's start with a simple question. What is a heat pump? Most homes in Canada have a air conditioner to use in the summer and a heat pump, a furnace to use in the winter. Now, some do not have an air conditioner. So the heat pump is an alternative, highly efficient, energy efficient system that does both cooling and heating. So it does cooling as required in the summer, which for some people could be an improvement, and heating in the winter, and it's all in one appliance, and that provides you consistent heating and cooling throughout the year. So it's a very, very efficient way of doing. It does not use fossil fuel, unlike the furnace. It basically uses some energy to transfer heat energy from one place to another, and thereby it can heat your home. It consists of an outdoor unit, an outdoor condenser unit. It consists of an indoor air handler unit. This is the simplest form. And it has the ability to extract heat from the cooler outdoor air and then transfer that heat indoors. People always ask me, how do you get heat when it's cold outside? And the simple answer to that question is there is always heat outside. It is, if your temperature is anywhere above what we call absolute zero, or minus 273 degrees centigrade, or minus 460 degrees Fahrenheit, there is some heat in the air. And it's all about extracting that heat energy from the cold air outside to bring that into the house and warm up the place. This technology costs a lot less to operate than conventional electric heat, and this automatically translates to lots of savings over the life of the system. In the summer, the system reverses from its operations and it becomes an air conditioner, so you get both cooling and heating. This picture shows you the cooling cycle, and then you have the heating cycle. It works exactly the same, just you're reversing the flow of heat energy. And that gives you another indication of how it works. What's most important in a heat pump is the efficiency of the heat pump. In other words, unlike a system which ramps from on to off and then on to off to keep the temperature warm in the unit, what the heat pump does is it ramps up to a set temperature and then makes minor changes to make sure that the temperature remains stable and the compressor is working very precisely to maintain that comfort throughout the operating time of the heat pump. This picture is a graphical explanation of how that works. So you have this green car, which is an inverter air conditioner pretty much. And what it does is it ramps up, reaches a set point, and then maintains that rather than the gray car, which heats up, then cools, heats up, cools, and so on and so forth. So obviously, this is a more comfortable ride, just like a more comfortable experience with the heat pump. There are different types of heat pumps. The simplest one is a single zone. This is ideal for a small home or a one room heating or cooling. That can be a multi-zone application, which up to 8 zones in a home for homes with no ducts. You also have a central system for homes which are new or with existing ductwork and furnace. And then you have a hybrid heat pump. This is where you have an existing natural gas or propane furnace, you leave it in place, which can be used then only as a supplemental or backup heating source. And what it does, the heat pump replaces the air conditioner on the outside, and in the inside, you put an A coil, which pretty much sits, it's a device like that, which sits right on top of your furnace and then uses the same system. And you have a control box that switches the furnace on only if required. And this gives you hybrid heating and cooling. And these are the different types of heat pumps, and then you have different capacities and different uh, features that you can go into. But I'm going very high level. The benefits of using a heat pump in a home as compared to a furnace. Number one, the furnace provides only heat. The heat pump provides heating and cooling. So you have one device doing both. The furnaces traditionally have energy efficiency only up to 99%, whereas the energy efficiency of a heat pump can be as high as 425%. And that means you have ongoing savings over the life of the system. That's important. The furnaces burn fuels, which increases the greenhouse gas emissions. The heat pumps do not burn anything, they just transfer heat energy from the outside to move it inside for heating mode, and cooling mode reverses it so that heat energy is extracted from the home and moved outside. So the furnaces increase the greenhouse gas emissions. The heat pumps produce no greenhouse gas emissions, which today is a hot topic and really important. So you have zero carbon emissions, and because it runs only on electricity instead of fossil fuels. The furnaces produce inconsistent heat because it cycles from on and off, whereas the heat pumps maintain that consistency of temperature and comfort throughout the operating life. So the occupants of the unit are comfortable at all points of time. The next we're going to do is compare the efficiencies of furnaces versus heat pumps. The term used for this is the coefficient of performance, or COP. It is a rating that tells us how efficient the heat pump or the air conditioner is at transferring heat versus the amount of electrical energy that it consumes. The higher the coefficient of performance, or COP, the more efficient it is at transferring the heat, and hence greater the savings. Let's talk about a natural gas furnace. Most people have this. It is available up to a 98% efficiency. So the COP is 0.98. The propane furnace also is available with efficiencies as high as 0.98. The electrical baseboard can have efficiencies up to 1. That means 1 unit of energy is used to generate 1 unit of heat. The heat pump does 200 to 425% of efficiency. So in other words, the COP is 2 to 4.25. And that means you have only 1 unit of energy going in to produce 2 units or up to 4.25 units of heat. Over the life of the system, that's a huge savings. Some more graphical examples to show you the efficiencies. The green line at the bottom is the efficiency of an oil furnace as compared to a natural gas furnace, as compared to electrical resistance furnace, which is 1. And in comparison, even at temperatures as low as minus 30, the heat pump can generate 126% of heat energy, or can move heat energy. So this is the efficiency curve for a 3-ton system from Mitsubishi. And even at winter design temperature, the cold climate heat pump operates at a higher efficiency than any other conventional system. And 90% of the time it's over 2. The COP is over 2. Why is this efficient? Simple graphical explanation of the principle. You have 1 unit of heat of electrical energy, which extracts 4 units of heat energy and transfers that indoors to give you 5 kilowatts of heat output. So that's how you get it. Is this cost effective? That's the biggest question all throughout. The cost of the device by itself can be around 3,000 to 19,000, depending upon the model and capacity. What adds up to the total system cost is the physical attributes of the home or of the building and the related installation costs. Even then, what you got to be more cognizant of are the ongoing savings on the utility bills, which in some situations can be as high as 50%. Now, in 2022, the Government of Canada, through Natural Resources Canada, they issued a report based on a study by CanMet Energy. And it was reported that energy savings, utility bill savings, and the greenhouse gas emissions reductions could be expected from installation of a cold climate heat pump or a hybrid heat pump when compared to conventional home heating systems. And this is a link to that report. Obviously, I'm not going to go through the whole report, but just so that you understand, this little graphic shows you the operational cost savings of heat pumps as compared to a gas furnace. And in Toronto, that's about $229 a year, which over a period of time will add up as the tax on gas keeps increasing. The operational cost of heat pumps versus an oil furnace is even more interesting. In Toronto, that's about $2,542 for a similar application, right? So heat pumps are great, all that, but how do you make sure that you're doing the right thing to make sure that your investment you're making is right for the long term and long-term future? It's all about peace of mind, ensuring that you have the best performance, most consistent heating and cooling. And so first and foremost, you got to choose the right contractor. That's very, very important. For that, you got to make sure that your contractor is licensed, bonded, and insured to make sure that they meet the professional standards and legal requirements. The next thing, check references and reviews. Go and find out more and gauge their own reputation. Look for a contractor that has specific experience in heat pump installation. Ask about their familiarity with different types of heat pumps, air source heat pumps, cold climate heat pumps, and so on and so forth. Confirm that, this is important, confirm that the contractor is trained by the manufacturer of the heat pump to ensure that your system is optimally installed as recommended by the manufacturer of the system. A good contractor will literally guide you through the decision-making process. They should be able to provide you a high-quality installation. They will analyze not just your heat pump requirement, they'll also look at the insulation, the ductwork, your specific heating requirements, and then come up with a true solution that would fit your application. Now, Mitsubishi Electric Sales Canada, we provide free training to contractors, and this certification must be renewed every 2 years so that they can maintain their certification. We call it the MEQ certification. So ask about the manufacturer's warranty, what warranty you're going to get, and what are the ongoing maintenance service costs to keep the system running efficiently. The most important thing, ask questions. That's the most important thing. Also, you want to choose the right manufacturer. Now, check the reputation of the manufacturer, see their reviews. Make sure that they have a wide enough range of product that you can get the right solution for your home and your application. So you're not taking any product that's oversized or undersized and trying to make it fit into your home. This will be exactly what you require for your home. Make sure that they're an established manufacturer that you can reach easily. You don't want to manufacture in some other country that you cannot reach in the event that you need some help. Okay, make sure that this manufacturer has a local inventory of product and spare parts, and they have their own local factory trained technical support just in case you need assistance in the future and you're not getting that from your contractor. Make sure that this manufacturer also conducts regular training for contractors. This will give you peace of mind throughout your system operation. Make sure that the manufacturer's warranty matches what the contractor has said is going to be there. Uh, this is very, very simple. I mean, you have to ask the questions, and at any point of time you need, just call us, call a manufacturer and ask who is, or verify that the manufacturer backs and supports the contractor that you're working with. I got some application samples or examples which show you a similar situation. You have a house in Campbellford, Ontario. We put in a system, and the customer found significant energy savings up to $4,000 per year. And they say it's extremely comfortable both during winter and summer. Victoria House in BC, uh, they achieved net zero emissions while keeping their operations quiet and comfortable throughout the life of the system. Their energy cost savings were huge. Another example is Harvard Village in Ontario. They have another system, again, consistent, continuous comfort, constant warmth, both in winter and cooling in summer, extremely quiet with low running costs. So it all boils down to choosing the right product with the right contractor, and we can give you many such examples if you ask us for it. I have a short video that I'm going to run, which kind of puts it all together, and then we'll come back and summarize the whole thing.
Oh, so now we don't hear actually.
Pardon?
We don't hear it.
Oh, I'm sorry. I'm going to stop
Maybe just,
sharing and come back.
yes. Yeah. Thank
I
you.
must have missed doing that. Hold on a second.
And thanks everyone. We'll be addressing your questions soon after the presentation ends. Keep writing them in the Q&A box meanwhile.
Okay. Why am I unable to do that?
So when you try to share the screen on the
Right,
bottom
right,
left, it says
right.
share out.
I will do that right away.
No problem. It's time of the experience to be online, but then it allows for so many other people to join at the same time. Okay, try again now.
Known for their poor efficiency and performance in cold weather temperatures, but that was then. This is today. Mitsubishi Electric Heating and Cooling's revolutionary heat pump technology and our Zone Comfort solutions can give everyone in your home total personalized comfort year-round, even in sub-zero temperatures. Here's how they work. Mitsubishi Electric's ultra-efficient heat pump systems consist of an indoor air handling unit and an outdoor condensing unit, which are connected via 2 refrigerant lines. Together, they work to efficiently transfer the desired heating or cooling energy to your personalized comfort zones. In summer, air conditioning is produced when heat energy from inside your home is absorbed by the system's refrigerant and transferred to the outdoor air. In winter, the refrigerant cycle is reversed and the system extracts heat from the outdoor air and transfers it inside to heat your home. For those requiring high-performance heating in colder temperatures and climates, our expert engineers have developed hyperheating inverter technology. Our hyperheating outdoor units use an enhanced compressor design to continue extracting heat energy, even when the true outdoor temperature reaches down to -25 degrees Celsius. When compared to other fossil fuel burning heating systems, our modern heat pumps provide exceptional heating performance while being a greener, more environmentally friendly option for your home. All of this is possible due to our advanced variable speed inverter compressor technology, which results in our systems using up to 50% less energy than conventional electric heating. In addition, a single outdoor unit can control up to 8 indoor units for added comfort and efficiency, with multiple styles available for added versatility. Our indoor units also feature true air filtration for your home, resulting in improved air quality with whisper quiet operation, perfect for any home, even a baby's nursery. For close to 100 years, Mitsubishi Electric has built a global reputation on quality and reliability. Our innovations continue to make heating and cooling more efficient, comfortable, and healthy. For more information, visit us at mitsubishielectric.ca. Mitsubishi Electric Heating and Cooling. Expect amazing.
Oh, so now you're muted.
Perfect. So last slide, and then we're done. In summary, heat pumps can contribute towards improving your heating and cooling comfort while saving money over the life of the system, and you'll be doing your part towards reducing greenhouse gas emissions. That's important. Mitsubishi Electric, we offer a very wide range of residential, commercial, heating, ventilation, and air conditioning systems that can be sized and optimized to meet your specific project's short and long-term goals. Uh, the solutions are available across Canada through an established network of distributors and dealers who are regularly trained by Mitsubishi, all backed by local support and service and spare parts inventory that's very unique with Mitsubishi. It's all about giving you peace of mind as long as you have the system. Uh, for any more information, feel free to call us or contact Mitsubishi Electric Sales Canada. You can contact us or our distributor or our dealers. And with that, I'm pretty much done. That's the main line where you can call and ask any questions on our website. And that's basically it. Thank you.
Thank you, Sanal, so much for this presentation and overview of everything we need to know about heat pumps. There are a lot of questions, and I'm going to start right away reading from them. I think you can take a breath because the first one probably can be addressed by Abraham, and it's about any rebates from the government or, in this case, from the City of Toronto on heat pumps.
Yeah, thanks, Nessie, and thanks, Sanal, for the presentation. So, as of February 5th, 2024, Enbridge had to pull out the rebate program, the HERPLUS rebate program. So across Ontario, there's not a rebate program for heat pumps right now for heat pumps. But as Desi mentioned, City of Toronto, we have the Home Energy Loan Program, and within that program, there is an incentive for heat pumps up to $2,500 if you were to install a heat pump in your home. Keep in mind, though, that you will have to access the loan as well in order to access the incentive. I'll put the link in the chat for the Home Energy Loan Program.
Thank you so much, Abraham. Moving to the next questions. In the NRCan report, why was the cost effectiveness higher in Winnipeg and Prince George? Is it more expensive to use a heat pump in those places? Sanal?
That was a study done by Kenmet Energy on behalf of Natural Resources Canada. And that's because the cost of gas in that part of the world is less than that is Ontario. Very much. That's why they make it.
Right.
That's a simple explanation. Yeah.
Yes.
Best way is to read the whole report. It's pretty interesting when you read the report.
And I think that's the report that I shared in the chat as well. Okay, moving on to the next question. Is the 1.26 COP at very low freezing temperatures for an air source heat pump? How does that compare to a ground source heat pump?
Ground source heat pumps are a better option always, but they're also extremely expensive. So it's balancing that comfort versus the cost versus what you were getting out of it.
Okay. However, do they have a better COP?
The ground source is a better system, yes. It's also very, very expensive compared to an air source solution.
Right. Okay. Next question is, thank you so much for the great session. Assume that 15 to 20% of existing housing stock will adopt a heat pump in the coming 4 to 5 years. Does the electricity grid have the capacity to deliver this incremental demand?
Oh, I'm sure they're working on it, and as the grid requires capacity, it'll be added. Everybody's working on making the whole thing work together. So I would take the decision to jump to a heat pump anytime today. Yeah.
And I can add
So,
into that as well.
yeah.
We have been in talks with Toronto Hydro, as they are aware that electrification is something that we've been pushing towards. And they did mention that there is capacity in the grid, especially in Toronto. If you want to learn more or talk to a Toronto Hydro representative who will be in the home show starting this Friday all the way till next Sunday. So feel free to come join us there, and you can ask Toronto Hydro representative there as well. And one of the things that I always talk about as well is because the electricity is much more, well, heat pumps are much more efficient than the furnaces, the amount of gigajoules we require is not as much as a natural gas furnace. So that also helps with talking about the grid capacity in the future.
Thank you so much. Candice, do you want to add something on that topic? I see your hand is raised, or maybe it was just by mistake.
I think I'm logged in a few places here, so that must be a mistake.
That's okay. No problem.
Sorry about that.
Okay,
But
we're going
by
to
the way,
continue.
I found Michael D'Souza, so he is here to answer any technical questions should they arise.
Okay, thank you so much. Yeah, we have a team behind here to answer your questions, and they're coming, so I'm going to continue reading it. One very interesting that was on my head as well, and it's in the chat actually, it's what are the typical maintenance costs for heat pumps?
Come again?
What are the typical maintenance costs for heat pumps?
That's a question, Michael, you can help with. Michael? I mean, it's very simple. Technically, you have a filter that needs to be cleaned regularly. You can do that. People can do that themselves, and they can also have a maintenance contract with your contractor to make sure there is regular maintenance done. It's a part of that discussion when you choose a contractor, if that makes sense. Yeah.
I don't know if Michael wants to jump in. No? Okay. Moving on to the next question, which is from Robert. I have a question regarding the backup system for the heat pump. What is the most economical backup system for a house in Toronto with an existing ANG furnace?
First and foremost, economically, the best solution would be to use a cold climate heat pump, which can work as low as minus 25 degrees centigrade. As far as the backup heat, that depends on your specific home and how you need to heat it. You can that's a discussion to be had with the contractor at any point of time. Yeah, they can give you options. Get lots of options and quotes from different contractors as you make your decision.
I also will advise you to watch. We had a webinar just 2 weeks ago with experience of 2 homeowners in Toronto, and they had a backup system. So maybe I will try to find the link, or Abraham, if you can find it, and then you can take a look, because they had a real example of a backup system. So the other question is, can a heat pump be installed in a condo unit where there is no furnace, but the water heater is used to heat the space via an air handler, and an outdoor AC unit on the deck provides the cooling currently? Sorry,
we have applications like that. We have applications.
Which is kind of like related to another question on your presentation. At the end, there was a unit that is mounted on the wall. Is that example of heating a home without existing ductwork?
The ductwork, the ductless systems, yes.
The ductless system. Okay.
So you have different flavors. You have you have ductless systems and you have ducted systems. The ductless systems are available 1:1 or 1:up to 8 units.
So on the question of can it be installed in the condo unit without a furnace? Yes, because we
have some examples where they're installed in a home, in a apartment unit with the outdoor unit just outside in the balcony and feeding into the place. Yes.
Okay. Thank you for answering this. David Wilson is asking, does Mitsubishi have low GWP refrigerants? And here there's a number, R290.
R290, yep. We do know that there's going to be a change of refrigerant permitted in Canada. A2L refrigerants is where we're going. We do have solutions coming up in place, yes.
Okay. This is like a follow-up question from the previous questions, but going back to the condo, is there still savings given it is a much smaller space if you use a heat pump in a condo?
I mean, the savings is in the fact that you're not using as much energy, number one. Number two, you are doing your part to reduce greenhouse gas emissions. So, yes, there are savings.
Next question. Sorry, I'm reading this for the first time as well, and it's actually 5 questions in one, but give me a second here. What happens to a centrally ducted HP system during the defrost cycle? Does the air handler still operate? Does the HP blow cool air through the ductwork? And how long is a defrost cycle, or does it depend on how icy it is?
That is a technical question where I'll need some help. I'm not a technical person, so.
Is that
but we
Michael?
can get back to you if you go from anonymous to a known attendee, we can get back to you.
Okay. I can type in this in the chat, and if someone from Mitsubishi wants to answer it in the chat, that's also an option. So please feel free to, I will answer this. Okay. Thanks, Candice. Next question. In terms of corporate buildings, what would the recommendation to council look like to start investigating investment into heat pumps in municipal buildings?
I guess I can answer this. It sounds more of a City of Toronto question.
Right.
We actually recently had a bylaw for building emissions performance standard bylaw that come into that we're still working on towards getting the implementation stage, but it's been recommended by council. We're moving forward with it, and it's a big thing of my of what our team is working on. So how that affects this technology is because starting this year, we'll need smaller footprint buildings or building owners to start reporting their emissions. That means, their water usage, their natural gas usage, and then their electricity usage. And then this will allow us to benchmark what the buildings are using or emitting in terms of greenhouse gas emissions. And from there, we can say, okay, we can set targets. Over the next couple of years, you'll need to be able to cut down your emissions by so much. So I hope that answers the question. But basically, we're saying, we've already pushed it to council and they've given the go ahead.
Yeah, and I can jump in on this because Clean Air Partnership works with a lot of municipalities in Ontario, 40 plus, and it is when presenting that it's reducing greenhouse gas emissions, it aligns with the city target for net zero, and at the same time there is a cost effectiveness and return of investment, like save cost. These are the two main kind of points to make council invest. It's just there is really a return of investment because you're saving on electricity.
And the other part of the question, sorry, Desi, is on municipal buildings as well. And for municipal buildings, the Toronto Green Standard is we have a much more stringent standard for municipal buildings, for City of Toronto buildings, as to other buildings within the City of Toronto. So we're actually already requiring net zero emissions for city buildings. So for example, the North Scarborough Community Center that's being currently built, that's going to be built to net zero carbon standards. So the heat pumps is definitely a big portion of that as well.
Right. Abraham, since you're on the call here, can you answer the other question, which is from Jason? How long does it take to get the $2,500 rebate and apply for the loan in Toronto? And does every homeowner qualifies?
Great question, Jason. Basically, the rebate will be provided to you once you completed your project. And the application process takes somewhere between 2 weeks to 2 months. It really depends on the lender consent from your mortgage provider. If you don't have mortgage, it's much easier to get the loan from us. But if you have a home in the AM postal code, then you can apply to the Home Energy Loan Program. And I've put the link into the chat for the Home Energy Loan Program.
Thanks, Abraham. That's very helpful. There were a few questions here in regards to noise. One of Andrew is sharing that their neighbor has a air source.
Yeah, I saw that question.
Yeah, and it's working hard. And down there is another question of like how much noise actually heat pumps make. Can you elaborate on that?
A good heat pump is relatively very, very quiet. A Mitsubishi cold climate heat pump is among the quietest in the world, and you wouldn't even know if it is working. You'd actually have to go and check and confirm. It's so quiet. I have many customers who have installed them, and I have friends who have installed them, and they always ask me, why is it so quiet? So it's a different way of looking at it, yeah. But if you buy a good heat pump manufactured with that low noise threshold, you should not have a problem. I know we make them.
Right. What is the life performance of a heat pump?
We
know that for furnace is like 10, 15 years. What will be for heat pumps?
About the same.
About the same.
We have heat pumps that are has been installed over 10 to 15 years, and it all boils down to making sure they're clean, the filters are cleaned regularly, and they're maintained properly.
Right.
It's like
a question. Yeah. Question from Zoran. How complicated is to add air source heat pump to existing ductwork? What is price difference between the air conditioner and the air source heat pump?
Great question. How complicated? Technically, not very complicated.
Oh, sorry. So now I think I lost you. Did you?
We got Candice. You want to say something, Candice?
I'm not hearing you.
Michael, sorry, there's just some crossover with the link. So I have Michael here.
Hi, hello.
Hello.
So the question is how the difference in work that's needed to be done for an air source heat pump versus a typical furnace.
Yes.
Well, generally, so with the furnace, there would be no outdoor unit, but most homes in Toronto and North America have air conditioning already. So let's say you would choose to use an air source heat pump on a centrally ducted system. It would just be essentially be replacing your air conditioner that most people already have in their home with a heat pump, and then using the centrally ducted system and air source heat pump indoor unit in replacement of the furnace. So essentially, the work is quite the same, especially if you already have an air conditioner in the home. There was another question that I was trying to answer previously with the defrost cycle. I'm not sure if I can circle back and answer that now. Is
Yeah.
that a good time?
Yeah.
Okay,
Please go.
so we do have the flexibility of having the indoor fan operating during defrost cycle, and also we can disable the fan during defrost cycle. So you can eliminate the fan so that you're not blowing any cold air into the space, but you can also allow it to come on if the system needs to come on, which would be during a low temperature situation. So, for example, if my indoor temperature was below my set point, the system would allow the fan to operate if you had an electric heater on top, so that during those defrost cycles, you can still provide heating within the space. So we have the flexibility of choosing the fan to be on or off, depending on the customer's preference.
Thank
How
you.
long is a typical defrost cycle?
Depending on the product, but typically the maximum time would be 10 minutes to 15 minutes on some products. But on our P series lineup, a lot of the defrost cycles are very short. It has a very advanced defrost system, and the logic is made so that as soon as it senses warm temperatures or warm enough temperatures on the coil outside, it'll quickly get out of defrost and go back into heating. So in some situations, you may have a defrost cycle that lasts 2 minutes, which is, a common time frame. And obviously at colder ambient temperatures, it can last up to a maximum of 15 minutes. It can never exceed 15 minutes.
Thanks. I think maybe since you're in the call, I don't know if that's a question for you, but is there any like how a person getting a heat pump needs to decide where to locate the outdoor unit? Is there any preferable way of putting the outdoor unit?
Yeah, absolutely. It's a great question. So we always recommend to have the unit installed on a stand, 18 to 24 inches above ground. Okay, so that would allow for any defrost, any condensation below the unit to be moved away from the bottom of the unit, so that there would be no ice buildup reaching the bottom of our
Kind of
outdoor
lost
unit.
you. Is it just me?
Can you still
Abraham,
hear
you
me?
here?
Yeah, I'm good. I think it's just you, Desi.
Oh, okay. Sorry then.
I said that too soon.
Oh, okay.
Michael's frozen.
Okay. Maybe they'll be back. Dave, okay, yeah, I guess it came first to me. That's okay. We're gonna take more questions. Oh, or actually, Abraham, the question was partially of the question was like where the outdoor unit is located. Are there any Toronto requirements for that?
There is a bylaw that restricts installing a heat or a condenser in the front yard if there's less than, I don't remember exactly, 6 meters of clearance, but it's only into effect if if you're getting a building permit. So most of the time, I think if you're just replacing a heat pump from an AC unit, you don't need a building permit, so then it doesn't really kick in. But
Right.
yeah, that's the bylaw.
Okay. Great.
Hi, sorry about that. Did you already move on to my question?
No, partially Abraham was answering if there is any bylaw, but please feel free. You kind of like jump in the beginning, so feel free to start from the beginning.
Okay, no problem. So the first thing we always recommend having the heat pump installed on a stand 18 to 24 inches above the ground. This will allow for any water during the defrost to not accumulate to the bottom of the unit, which could damage the outdoor unit. So you always want to have it on a stand. The other mention would be to not put it near any walkways or near driveways or where anyone will be walking, where there would be heavy traffic by pedestrians, by other occupants in other buildings. So you want to make sure that the ice that is accumulated below the unit does not interfere or with anyone walking by it, so there's no slipping or falling. Okay, and then the other mention would be to make sure that you do have a little bit of a grade slope away from the home, so that all of that water will be pushed away from the house and not accumulating at the foundation of the home. So those are generally the locations that we always recommend. Noise considerations are always something that we mention. However, as Sanal had mentioned previously, the outdoor units are relatively or very quiet. So the noise considerations is not as big of a concern than the ice considerations.
Again, it boils down to talking to your contractor and choosing the right location, and they would do it right if they're trained right. So choose the right contractor. And always you can get back to us if it's our product. Get back to us and we'll be glad to help.
I think kind of like this summarize the two questions here that Zoran is asking of, like how difficult it is to connect the air source heat pump to a gas combo system. I think that's all it's going to be determined with your contractors. Is that right? You can get that information from the beginning.
I didn't understand. Sorry.
I can speak to this. I went through a transition from full gas to hybrid, and what was required was, like I had mentioned before, we switch out the air conditioner on the outside. On the inside, we're then replacing an E-coil that I have on top of my furnace. We replace it with our indoor unit, which is called the PAA. There's also a control panel, which was mentioned, that is set up where we're able to define the temperature where we're switching from furnace to heat pump. And it wasn't a complicated installation at all. Took maybe half a day or a little bit more. I mean, there's always going to be things to consider depending on your home, where your current air conditioner is, if there's room to connect the outside to the indoor unit. So a lot of things to factor in, but in general, like we mentioned, it's around the same as what it would take to, install a furnace. Yeah. So no, and to also speak to the noise, I'm not sure if is anyone on this call who has a heat pump, but I remember last summer I went to my friend's house and we were all sitting outside in the back, and she had her air conditioner running, and I remember thinking that, like, I can't hear a word. You're talking above the air conditioner. And then I got my heat pump installed, and I could not believe that I could not hear a sound. And it's like someone had mentioned, you often just don't even know that it's on. And I think with an air conditioner, we all agree, you hear it when it's on. And with this, I could not. And to me, outside of all the other benefits a heat pump has, to me, this is just, icing on the cake. It truly is an amazing feature of this product.
Thanks so much, Candice. And it's so very nice of actually sharing personal experience of you having a heat pump. I mentioned once again, but we did have a webinar, and same thing about the noise. We had a webinar with folks who installed heat pumps, and they did share that it's quiet. We have a few minutes left. I wanted to address a question that actually, Candice, you answered live, but I see that there were a few related to that in regards to like how to find a contractor. And I think you provided a link, actually. Is that, does a Mitsubishi keep a list of certified contractors on their products? And you provided a link of that. So that's the way of how.
I believe it's there on our website.
Yeah, so just so you know, we provide training for our heat pumps. I don't believe that there is like a heat pump specific course. So, I mean, I can only speak for our dealer locator and the dealers that we train. So we know that there's Mitsubishi Electric certified heat pump installers on our site. I mean, I cannot speak for any other company in the industry with respect to any special training that they have had on heat pumps, because like I said, it's not like there's a course. So it might be in individual manufacturers' hands to train them on the installation of the specific products.
Right. No, that's thank you so much. And there is a link for the contractors that you share.
Yeah, and I know
just
have
kind of like on that topic, but what is the average install time for a heat pump? I'm guessing it depends on the type of the heat pump, but can you?
I think more the type of the home.
Yes.
Oh, it depends on the home.
It would really depend on the type of heat pump, right? So we have, as Sanal had mentioned, systems that one outdoor unit can support 8 indoor units. So on an installation like that, it could take maybe 2 days. As an example, a single 1-to-1 ductless splits, that could be done in, a couple hours. So it really varies as per the application.
Right.
Right. Great. Well, thank you very much. I think we are at the end. Maybe it seems that it's thank you, Abraham. Thank you. There was one question that I was debating, should I ask, but you actually answered a bunch. There is one that is very technical. I don't know if we have time, but maybe very quickly. Can single zone units be hidden in the attic and vent into the bedrooms for the ceiling?
Yeah, so that can be done. So we can have horizontal ducted units installed in the attic space, which can then be distributed to condition air into separate rooms within the second floor or in the first floor, depending where the attic is located. So that is a possibility.
Awesome, great. And I think that answers, and Abraham is answering the last questions, which this is great. Thank you very much for the whole team from Mitsubishi for being with us, for answering the many questions that we received, which shows that it is a topic of interest. And thank you very much for everyone that was on the call with us and for your questions. Thank you, Abraham, for organizing this. And I wish everyone a great day for the rest of the day, and stay tuned for more of our upcoming webinars.
Okay.
Thank you.
Thank you so much.
Thank you all.
Thank you. All right.
Bye.